Hello, how are you? I welcome you all. In the last class, we discussed rules for concave mirror and we have drawn ray diagrams for concave mirror. In this class, we will discuss about the convex mirror. So whatever the rules were applied for concave mirror, that rules are applicable for here, but a little bit difference because of convex mirror. Let us see the rules for convex mirror. Rule number 1. So convex mirror has curved outward reflecting surface. So oblique lines are taken inside of the mirror. A imaginary line passes through the center of the mirror, which is called the principal axis. So pole, this is pole, and this is focus, and this is center of curvature. Focus and center of curvature is taken inside of the mirror for convex mirror. So a ray of light parallel to the principal axis and it gets reflected like this. If you extend a dotted line from here, it touches focus. Then you can observe after reflection, the reflected ray appears to coming from the focus. A ray of light parallel to the principal axis after reflection, the reflected ray appears to coming from the focus. This is your first rule. Let us see second rule. Rule number 2. Convex mirror, principal axis, pole, focus, center of curvature. When the incident ray towards the mirror and it gets reflected like this. After reflection, the reflected ray will become the principal axis. If you extend a dotted line from here, exactly it touches again focus. When the incident ray appears to passes through the focus, after reflection, the reflected ray parallel to the principal axis. This is the second rule. Let's see the rule number 3. Rule number 3. When the incident ray towards the mirror and strikes the mirror, after reflection, it gets reflected back along the same path. Because of if you extend a dotted line from here, exactly it touches center of curvature. If any ray passes through the center of curvature, that ray act as normal at the point of incidence, it makes 90 degrees angle. Here principal axis is also passes through the center of curvature. This principal axis act as a normal at the point of incidence, it makes 90 degrees. So a ray of light towards the mirrors and it appears to passes through the center of curvature and it gets reflected back along same path. This is the third rule. Let us draw the ray diagram by using any two possible rules out of these three rules. Then image can be formed. Let us draw ray diagram for convex mirror. Ray diagram. Ray diagram for convex mirror. Convex mirror has curved outward reflecting surface. So oblique lines are taken inside. So this is the principal axis, pole, focus, and the center of curvature. Let the object be placed anywhere in front of the convex mirror. Your image is always formed behind the mirror in between pole and focus. Let us see. This is your object A and B. We can use first rule. A ray of light parallel to the principal axis strikes the mirror. It gets reflected like this. If you extend dotted lines from here, it touches exactly at focus. But we cannot use the second rule. It is not applicable for here. We can go with the third rule. From the object, your incident ray towards the mirror, and if you extend like this, it touches the center of curvature. Your incident ray appears to pass through the center of curvature. It gets reflected back along the same path. Where the dotted lines are intersect, that point is your image location. So your image is A dash and B dash. Now we have to write the nature of the image. Nature. So your image is formed behind the mirror in between pole and the focus. Image is formed behind the mirror in between pole and focus. Here, reflected rays are not really meet at this point. So imaginary lines or dotted lines are intersect at this point. That's why this image is virtual. This image is virtual. All virtual images are in erect. So this image is virtual and erect image. So when compare the image size with object size, definitely your image size is going to be decrease. So image size is diminished, small size, diminished. So finally, when the object placed anywhere in front of the convex mirror, always your image is going to be formed in between pole and focus behind the mirror for the convex mirror. So concave mirror can form real and virtual images, depends on the position of the object from the mirror. So concave and convex mirrors can form virtual images. So we will see comparison of virtual images are formed by concave and convex mirrors. So concave mirror. Here convex mirror. Concave mirror has curved inward reflecting surface. So oblique lines are taken outside of the mirror. So imaginary line, pole, focus, and the center of curvature. Let me draw convex mirror. Oblique lines are taken inside of the mirror. This is the principal axis, pole, focus, and center of curvature. So when the object is placed between pole and focus, we can use the first rule. A ray of light parallel to the principal axis strikes the mirror. After reflection, the reflected ray passes through the focus. This is the reflected ray. We can use the third rule. A ray of light strikes the mirror and reflected back along the same path. A ray of light strikes the mirror and reflected back along the same path because it is passing through the center of curvature. If you extend dotted lines from here, these two dotted lines can intersect at this point. This is your image. Your object is AB. Here your image is A dash and B dash. Now we have to write the nature of the image. Nature. Image is formed behind the mirror. Image is formed behind the mirror. And the next point, image is virtual because of dotted lines or imaginary lines are intersect at this point. Virtual image. All virtual images are erect. Virtual image and image is erect. So upright. So you can observe your image is enlarged when compared to the object size. Enlarged image. Let us see for convex mirror. Let the object be placed anywhere in front of the convex mirror. Always your image is formed behind the mirror in between pole and focus. Shall we use first rule? A ray of light parallel to the principal axis, it gets reflected like this. If you extend dotted lines from here, that dotted line touches exactly at focus. Here second rule is not applicable, that is violated. We can go with the third rule. A ray of light from the object towards the mirror and strikes the mirror. If you extend dotted lines from here, exactly touches center of curvature. When the incident ray appears to passes through the focus, it gets reflected back along the same path. Where the imaginary lines can meet, that point denotes image location. Image. You can observe your image is formed behind the mirror in between pole and the focus. A dash and B dash. Now we have to write the nature. Nature of the image. If you place anywhere in front of the convex mirror, always your image can be formed behind the mirror in between pole and the focus. Image is formed behind the mirror in between pole and focus. Your image is virtual because of dotted lines or imaginary lines can intersect at this point. So image is a virtual image. All virtual images are erect. Virtual and erect image. You can observe your image size will decrease when compared to the object size. So here image is diminished. That means small size. So irrespective of concave and convex mirrors, when the object is formed behind the mirror, that image is virtual. When the image is formed in front of the mirror, that image is real. So this is the concept about the concave and convex mirrors. So today's class is completed. In the next class, we will discuss some problematic questions. Thank you.